What if I rotate about the x-axis instead of the y-axis? How is that going to change this whole setup for me? So let's do this problem where I do that. I rotate about the x-axis. Use cylindrical shells to find the volume of the solid obtained by rotating about the x-axis, the region under the curve, y equals the square root of x from 0 to 1. Okay. So let's look at our region here. I'm looking at the square root function between 0 and 1. 1, it's 1. And it's this curved kind of function here. And I'm only looking between 0 to 1. So this is my region right here, this little hill-shaped object. And I'm rotating, they tell me, about the x-axis. Now, we're using cylindrical shells. So let's take our strips. They need to be parallel to our rotation line. So should my strips be horizontal or vertical? I want it parallel to this line here. Horizontal. Okay. So my strips are going to be horizontal. So if you look at our strips, they're horizontal, which means I have a left and a right, which means we're going to be forced to integrate in terms of y. So keep that in mind, integrate in terms of y. So let's find our radius here. Now you might need to turn your head to think about this. The radius is the distance to my rotation, from my strip to my rotation line. So the radius in this picture is going to be that blue distance right there. This guy here. And that's just y. And I'm integrating in terms of y, so I can leave it just y. All right, now I need the height of my strips. So the height changes, it's stuck between these two functions. So remember, we do right minus left when we're integrating in terms of y. So this whole distance here to this line is 1. And then this distance right here, this is x, because it's a horizontal distance, it's x. So it looks like my radius, or sorry, my height is 1 minus x, but remember I'm integrating in terms of y. So this needs to be in terms of y here. This x comes from this function this function right here, y equals x. So I need to solve for x in that equation. What do I get when I solve for x in that equation? Y squared. So if you take in this equation, you solve for x, you're going to get x equals y squared. So it's 1 minus y squared. That's your height. Once you know your two things, once you know your radius and your height, you're good to go. Set up your volume. So 2 pi r, which is y, the height, 1 minus y squared. And then I got to think about my bounds. Remember, your variable is y. Y went between 0 and 1. So these numbers here, 0 to 1. Okay. And again, this integral isn't that bad. Factor out your 2 pi, y minus y cubed, and integrate. 2 pi y squared over 2 minus y to the 4th over 4. And I believe you get pi over 2 for this.